Hi guys, day 2 of contingency plans. Yay! So in day 1 I noticed that a lot of us were struggling, and I reflected on it and realized that these problems were kind of harder than what we had done in class. So after talking with a couple of teachers, I thought that we would kind of change it up for today. And so if you notice, we're still dealing with exponents, but we're using a different rule today. And we're going to be using the quotient rule. Okay, and remember with the quotient rule, when you have the same base, so that's the large number, subtract the exponents. So a quick little example of that, I'm going to do 2 examples. So if we see something like g to the second, no, I don't want a 2. Let's go g to the 7th over g to the second. There I got my 2. Then all you do, you think, well, what's 7 minus 2? Well, that's 5. So g stays the same, and then we just add the 5 in our exponent spot. Same way is if we switch those 2 terms around. So if we have g to the second over g to the 7th, we're still going to subtract our exponents, right? So instead we're going to think 2 minus 7, and that equals negative 5, because if we start at 2 on the number line and go subtract 7, we're going to go left 7, 1, 2, 3, 4, 5, 6, 7. Hey, that was pretty close. And you get negative 5. So then g squared over g to the 7th would be g to the negative 5th. But then remember, notice how the directions say you have to have positive exponents. So what that means is this, g to the negative 5th, we really see that as g to the negative 5th over 1. And this minus sign tells us we have to move the g to the negative 5th into the denominator. So then we have a blank in the numerator because there's nothing there now, and then it would be g to the 5th, and we get rid of that negative sign because we no longer need it. That negative was essentially our direction to say, move me to the other side of the fraction bar. But then the question remains, what goes in that numerator? And the answer is, it's not nothing, it's also not 0, because then our answer would be 0. It would be 1. All right, so there's a quick little reminder. Now I am going to do one of them. None of them are done on your paper. So hopefully like you take a screenshot or you pause the video and split screen or something so you can see this part. I'm actually going to do 2. I'm going to do number 4. And I'm going to do, number 4. And I'm going to do number 10 because both of these are problems that I noticed had some challenges with people kind of today as well. Okie dokie. So here we have kind of 2 problems. I'm going to highlight them. So we see this 2/10, and then we also have this w to the 5th and w to the 7th. So we're going to kind of go at them in different ways. I should have highlighted with orange or something because I'm going to, instead of writing in yellow, hard to read, I'm going to use orange. So if we split this up and think, well, what's 2 over 10? It's just a fraction, guys. 2/10 is the same as 1/5. So that's the yellow highlighted part, or now orange. And then I'm going to change it to green. And then the next part would be w to the 5th over w to the 7th. So now I'm going to subtract my exponents. So that's 5 minus 7, which is negative 2. And so that means w to the 5th over w to the 7th would be w to the negative 2. So that means right now my problem is 1/5 times w to the negative 2nd. And you might be asking, well, why are you multiplying? Because remember, if you see a number next to a variable, there's an invisible multiplication sign. So now we have this w to the negative 2nd, but we all know that we could, I'm going to just rewrite the 1/5. We could instead write this as w to the 2nd in the denominator, then add that 1 up top. But then this multiplication, we don't have to have this fraction separated. We can combine it together. So we have 1 over 5w squared, and that's my answer. All right, with number 10, a similar setup. So I'm going to do highlights. I'm going to learn from my mistake and highlight in orange and green. Okay, so splitting this up, I'm going to kind of work on top a little bit higher. So 6/9 divisible both by 3, right? 6 divided by 3 is 2. 9 divided by 3 is 3. So I have 2/3. And then I'm going to go even higher in b to the 4th over b. Now, something that also to remind ourselves, this is part of the reason why I picked this one. B is not just a b, it's also b to the 1st power. So we're going to subtract, well, what's 4 minus 1? That's 3. So that means b to the 4th over b to the 1st would be b cubed. So 2/3 times b cubed. But that looks a little funny. So remember how b cubed is the same as, b cubed over 1. So then we can do the same thing we did here by kind of combining our numerators together and our denominators together. Sorry, word bungle. So it would be 2b cubed over 3, and you're done. Just because you see a 3 in the exponent spot and a 3 in the denominator does not mean that you put them together. So there I had it. I did number 4 and number 10. Do not just write the final answers, guys. Show me you did some subtracting. Show me some thinking, please. Please ask your math teacher if you have any questions, Ms. Arnold, Mr. Eckerly, or myself, or Mrs. Silman, Mrs. Breidenbach. Anyone you usually reach out to, please continue to do that. We are here to help you. Have a great Thursday, guys. Bye-bye.